Hello, my name is Chris Champion. I'm a student at Nicholls Online, and this is my video for the PSET 121 Module 6 assignment. Alright, the purpose of this video is to describe and demonstrate the steps involved in solving problem number 6 of the Chapter 6 self-test, located on page 183 of Applied Mathematics for the Petroleum and Other Industries, 4th edition, by Will McNair. So here's our problem. How many barrels will the cylindrical tank in the sketch below hold? The sketch describes a tank with two half-spherical ends with a radius of 7 feet and a main body cylinder with a radius of 7 feet and a length of 28 feet. The hard part here is that we have a two-dimensional sketch of a three-dimensional structure, so we need to use our imagination to see the tank and its half-sphere ends. So the first thing that we should take out of this is that it is a volume problem. For the first part of this problem, we are going to break down the structure into two parts: the middle cylinder and the spherical ends. For the middle, we have a cylinder 14 feet in diameter and 28 feet in length. Next, we are going to combine both of the half-spherical ends of the tank to create one sphere with a radius of 7 feet. We find the volume of each part of the tank, the middle and the ends combined, and add them together, and we'll have the total volume of the tank. So for the first part of the problem, we're going to be finding the volume of the central right cylinder. The formula for finding the volume of a cylinder is here. V equals pi times r squared times h, where V equals volume, pi equals 3.1416, r equals the radius of the end face of the cylinder, and h equals the length of the cylinder. So the formula reads, the total volume of a cylinder is equal to the radius of the ends of the cylinder squared times the length of the cylinder times pi. Now we can substitute the dimensions of the central portion of our tank into the formula. Knowing that the radius is 1/2 of the diameter, we know that the radius of the tank is 7 feet. Plugging this into our formula gives us 3.1416 times 49 times 28. This equals 4,310.2752 cubic feet for the volume of our cylinder. Next, we have to find the volume of the ends of our tank. If you remember, we combined the two half-spherical ends of the tank to form one sphere that was 7 feet in radius. Here is the formula for finding the volume of a sphere. It reads, the total volume of a sphere is equal to the radius of the sphere cubed times pi times 4/3. Now we're ready to substitute our dimensions into the formula. With a radius of 7 feet, our formula is now 4/3 times 3.1416 times 7 cubed. Multiplying these gives us a volume of 1,436.7584 cubic feet. Now we can add together the two volumes of the parts of our tank. Taking the volume of the ends and the volume of the central cylinder, adding them together, we come up with a total volume of 5,747.0336 cubic feet. Now, the problem question did not ask for the answer in cubic feet. It wanted an answer in barrels. So for the final portion of our problem, we have to convert our cubic feet into barrels. 1 barrel equals 5.6146 cubic feet. So all we have to do is divide our answer in cubic feet by 5.6146. Doing this gives us an answer of 1,023.59 barrels. And that's our final answer. Thanks for watching. I hope this video helped you understand how to solve such a problem.